Number 36. Lasers can be constructed that produce an extremely high intensity, blah, 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 blah. Okay, maximum electric field strength of 1 times 10 to the 11th volts per meter for a time of 1 nanosecond. Letter A. What is the maximum magnetic field strength in the wave? All right. So, so basically, once we know the maximum electric field strength, we can calculate the maximum magnetic field strength by the following relation. That the maximum electric field strength divided by the maximum magnetic field strength will be equal to the speed of light. So if I want to find B, just simply cross multiply this. And now plug in that electric field. So 1 times 10 to the 11th volts per meter, those are the standard units, divided by the speed of light, which is 3 times 10 to the 8. And that's all that we need to do now, right? That's it. So nice and easy. So 1 times 10 to the 11th divided then by 3 times 10 to the 8. And this is now 333. And that's in Tesla. Okay, that's the magnetic field. All right, so that takes care of letter A. All right, let's move on to now letter B. So this is then going to be, what is the intensity of the beam? So we can do this in a couple of ways. I don't know, why don't we just use the electric field strength that was given instead of using the magnetic field strength, although we could, just in case we made an error, right? So the intensity here is going to be equal to the speed of light multiplied by the permittivity free space multiplied by the electric field strength maximum squared divided by 2. So here now, the speed of light is 3 times 10 to the 8. The permittivity is 8.85 times 10 to the minus 12th. The 1 times 10 to the 11th squared, that's the electric field strength, and then divide that all by 2. All right? So just take out that calculator, plug it all in. 3 times 10 to the 8 multiplied by 8.85 times 10 to the minus 12, multiplied by 1 times 10 to the 11th squared, and then divide that by 2. So this works out to be 1.33 times 10 to the 19th, all right, watts per meter squared. So that takes care of now the intensity. And then how about now letter C? So letter C now says what energy does it deliver on a 1 millimeter square area? So basically what we can do now is it says what energy does it deliver, right? So we have to somehow calculate now energy from this particular formula here when we're dealing with watts per meter squared. So I think what we're going to have to do is we're going to have to calculate basically we're going to have to calculate the energy per second. All right. So so why don't we? The problem is because we don't necessarily. Oh no, excuse me. We do know the time. Sorry, I almost didn't realize we do know the time. All right. So what we're going to do here is we're going to take this value, 1.33 times 10 to the 19th watts. Now a watt is a joule per second. And then the meter squared is on the bottom. So this is a watt, meter squared was on the bottom, so hopefully that makes sense. Now what I want to be left with is just the joule. So I got to cancel the seconds, so I'm going to plug in my time. 1 nanosecond, but you know we need that in seconds, and that's just simply 1 times 10 to now the minus 9th seconds. So the seconds go bye-bye. We'll see you later. So now we have joules per square meter. But we don't want joules per square meter, we just want joules, so we got to get rid of the square meter. But the problem is they gave us a millimeter square area, right? So what we got to do is meters on the top, millimeters on the bottom. Then for every 1 meter, or you can do it backwards, it doesn't really matter. For every 1 meter, there are 1,000 millimeters. But now you got to square this whole result because you need the meters squared. And then you will be left with square millimeters, right? And this now will tell us the energy that is delivered over a square millimeter, okay? Well, okay. But just to finish it out then, right, we would have to then plug in the 1 millimeter squared. 1 millimeter squared, and then as you can see, those would cancel, and because it's, you know, don't forget that squared in there. And yeah, okay, just calculate. So this is then 1 point, and at this part of the class, you know, we're going relatively quickly with these conversions here because we have to assume that at some point, right, these are picking up. So let's take that value, then multiply by 1 times 10 to the minus 9th, divided then by 1,000 squared. And now this is going to be 1.33 times 10 to now the 4th. All right, and that's going to be now in terms of joules. So that's the energy. Guys, thanks for tuning in. I do hope this helped. If it did, check out some more of our videos. All right, we got a whole bunch of subjects out there for you. Take care.